Hey guys, how's it going? Does your robot vacuum seem to not be itself lately? Does it seem to be misguided and not sure where it wants to go? Are you not sure whether to call an exorcist, or a repairman, or the trash man? Well, look no further. Hopefully with this video, I'll be showing you how to fix some of these problems with your robot vacuum, specifically the EUFY Model 11, which this problem commonly inflicts, whether it be the side brushes, the main brush, or the drive wheels. So what normally happens when these problems occur, and what I've been seeing a lot in these models, is the motors that drive the wheels and the brushes can have a tendency to internally short, which causes some of the problems you see here. Sometimes the issue will be intermittent, where it'll run fine a few times and then start going in circles and eventually giving you some alarms. For the wheels, specifically, the red indicator will stay on and it'll give you one beep versus 2, 3, or 4 for all the different possible faults. Something I have noticed on these models is, even though the side brushes do have their own fault, which should be 2 beeps with a steady light, they will actually trigger the alarm for the rolling brush. So the 4 beeps with the steady light can be either the rolling brush or the side brushes. This video will be covering the wheels. One of the quick checks you can do is, if your EUFY is running around in circles or not at all, is you can try to roll each of these wheels, and what you'll find in most cases, if you have an internally shorted motor, the affected wheel will be more difficult to turn than the other. And it's kind of hard to show in here, but if I spin this, the wheel continues to spin for maybe half a second, versus the affected wheel, you'll see it does not freewheel at all. You can do the same check with the side brushes. This one continues to spin freely. This one does not, so that's an indicator that this one is getting ready to start faulting as well. What we're going to have to do is tear this unit down. We'll have to remove some internal components, and we will inspect the motors, and if you're up to it, you can actually take the motors apart and clean up one of the possible sources of the short. Let's get started. First things first, be safe. No watches or rings. As always, it's a good idea to have a container to organize your screws. Battery releases, just squeeze the clip, pull it apart, remove the brushes, remove the dust hopper, release the rolling brush, And we are now ready to remove the lower part of the bumper. What you can do, which I've shown in another video, is troubleshoot the problems by unplugging the suspect motors. So the bumper itself is just suspended from this ledge here. All you have to do is lift it off, release this cable, and we'll go around and remove screws around the perimeter. There are 1, 2, 3, 4, 5, 6, 7, 8, and there's normally a screw here, but it appears it was either missed or this particular unit has been opened up before and the screw was misplaced. It appears there's 2 screws missing. Well, it's quite possible this one has had bad parts put into it. And just carefully turn it over. Preferably you should use a magnetic screwdriver so you don't lose any of the screws. And it's quite possible that this foam rubber bumper here is going to be holding the top half to the bottom, so you might have to peel that away a little bit. On both sides. And the top has no cables going to any of the internals. Now, in order to remove the wheel assemblies, we're going to have to disconnect all these cables and remove this printed circuit board. Keep in mind, anytime you work on a printed circuit board, there's a potential that any built-up static electricity that you might have in your body will discharge through the board and can possibly damage some of the sensitive components. So if at all possible, touch something metal before you work on the board, or even better, if you have a electrostatic discharge strap to put on, that would be optimal. That way charges will not be able to build up while you're working on it. The way these cables are laid out, you pretty much can only put them on one way, so it's not super important to label them. However, it's not a bad idea to do such. These 2 up front, they can be potentially mixed, but the way the cables are routed, the chances of that happening are pretty low. So now, if these have never been unplugged, they can be pretty tight. And always grab by the connector, not the wires. Alright, so now that all the cables are disconnected, there are 3 screws holding the board on. When you pull this board out, you have to be very careful with these detectors. They go into a slot right here, so make sure you pull the board straight out, otherwise you could bend or break the leads. If you do bend them a little bit, all you gotta do is just straighten them out a little. Everything will be fine. Alright, so with that board out of the way, you have access to both side brush motors, both wheel motors, and the rolling brush motor, as well as the vacuum. So for this particular EUFY, looks like we'll be pulling the wheel from this side. So these pods, you'll notice there are some cables running across them through clips. Again, it's a good idea if you don't think you'll remember where they go. Helps to take a picture and possibly even label which go where, but it should be fairly straightforward. So obviously we'll have to slide these out carefully out of the way. Then there are 3 screws. Actually, it looks like this side we will have to remove the rolling brush motor. You can see there's just one screw holding that one in. In a separate video, I describe how to check the transmission inside this. Because a lot of times this will pick up hair and dust and cause rolling brush faults. This motor is also susceptible to internal shorting, but most of the time it's the side brushes and the wheel brushes. Motors, excuse me. Alright, with that one out of the way, it looks like this wheel assembly is actually just held in with 2 screws. On the other side, there are 3 screws holding it in. One here, and one here. Alright, well, this was my mistake. There are actually 3 screws on this one as well. This sensor and bumper switch assembly just needs to be lifted off. And again, it might be held in with this piece of foam rubber. Alright. So here is our wheel assembly. Now the wheels and, just the wheels have what's basically a encoder or resolver that determines the speed that the wheels are spinning at, so that it can synchronize. Since they're individual driven wheels, it lets it know what basically RPMs the motor is turning. Okay, what we need to do is release this wheel from this housing, and what we're going to have to do is release the spring. And for this part, it does help to have a dental pick. And we'll have to press out this pin. To open this cover. Remove this gear. 2 screws. And the motor is out. And just to be sure, you can now spin it and see that everything is now moving freely. Alright, on this particular one, it looks like we'll have to do some desoldering. Very carefully, you'll have to pry this flag wheel or sensor wheel off of the shaft, which if possible, if you can reach under and hook on the surface, trying not to bend the tines, pops right off. And it's plastic, so it's fairly resilient. And once that's off, we can now desolder the tabs, and we'll open up the case to see what's going on. Here I have the board and the motor now desoldered from each other. The positive lead on the motor is marked with a red dot, but I've also marked with a Sharpie, plus and minus. That's going to tell you which way to reinstall this board. It's marked with a plus. Alright, so the next step, we'll just pull this pinion gear off. Try to clear some of this grease out so we can gauge how far on it is installed. And it looks like it's about a 32nd of an inch gap, almost the thickness of a credit card. That's what I usually go by when reinstalling these. So in this case, the shaft is splined. And now we're ready to remove the end bell of this motor. In order to do that, we're going to have to bend these tabs out, and we'll be ready to slide the end bell out. Alright, so now we're going to have to remove these shims here. There's going to be a varying number depending on the motor you have. Just be careful when you remove them not to lose them. The reason they're on there is to make sure that there's no back and forth end play. Sometimes it's easier to do one at a time. Like I said, be careful not to lose them. You'll need to reuse them later on. And also, when you're prying up on these, hang on to the shaft down here so we don't risk damaging these brushes. So it looks like there's just 3 on this one. Alright, now before we remove this end bell, you want to make sure and take note of this index mark here. Almost every electric motor will have this index mark so that you can make sure and get the timing correct on this end bell. If you put it in the wrong direction, the motor may or may not run, and if it does run, you will not be running at maximum efficiency. So in this case, I've put a small mark with a Sharpie, and there is a notch in the plastic itself here, so it's not absolutely necessary. In this case, this end bell has 3 different notches, so went ahead and marked that one just to be sure we put it back in the right spot. Now when we pull this out, we want to make sure and be careful not to damage those brushes. Optimally, as you pull the end bell out, you should spread the brushes out away from the commutator. But in this case, it's a fairly light spring pressure, so I'm just going to go ahead and slide this out carefully. And now we have the brushes out, and we can clean those up. These actually look like they're in pretty decent shape. Again, I apologize for the poor lighting in here, but despite that, it would be really hard to show in this video. The gaps between these commutators are filled with the same dust that's lining the inside of this can. So I'll probably do some still photos of when I did one of the side brush motors. It shows a pretty good picture of exactly what's happening with these motors. You can use a dental pick or the end of a hobby knife to scrape them clean, and you can also just clean the inside of the can, get that dust out of there to help clean it up a little bit. Also, what you'll see that I've done with the side brush motor is dress the commutators a little bit so that they have a nice smooth finish for the brushes to contact. With that said, here are some of the stills of what I did. You can see here that the commutator is filled with the black carbon dust or graphite. I'm not sure what material is being used in these brushes. And once they're cleaned up, they can be polished up with some very fine sandpaper, or even steel wool works fairly well just to clean it up a little bit. I've already gone through these. There were two that were completely bridged. And also the inside of the can was pretty dirty, as you can see. And this spacer is actually shims, so it's possible you'll have several stacked on one another. In this case, this one has three shims. Once you have the commutator cleaned up, don't forget to put your shims back in. And your brush assembly will actually only go in one way. There's a notch right here that corresponds with this notch right here. Might be hard to see in the video. There's a notch there. The same thing, we're going to need to make sure we spread the brushes out. Feed them over the shims. Make sure we get our notch lined up. Then make sure the end bell retainer is nice and clean. Snap it into place. And then we will recrimp all these points. So there's a few different ways that these can be recrimped. You can use a punch to stake these over. In other motors, there's actually a tab that can be bent over, again, using a punch or a screwdriver. In this case, it's just the can itself is crimped in 4 places. Just make sure you're pushing it in to make sure it's seated in the right position before you crimp it down. Alright, so those feel pretty good. And just give the motor a spin. Make sure it spins free. And also test it with a 9-volt battery. Alright. That's what I like to do when replacing pinion gear. Is just use a credit card or business card. And that's about the right gap, so there's no binding. Next, we're going to solder our resolver or encoder board back on. Again, remembering the red dot is positive. It goes to the positive terminal. And here's the board resoldered. And the board sits flush with the raised proportion of the back of the motor. And then we will reinstall the flag. And again here, make sure you leave some space between the board and the flag. And just in case you're wondering, there's a emitter and a detector. It basically beams infrared out of one and then into the other, and each of these flags will cause a signal that tells the computer on the main board how fast or how slow the motor is spinning. Alright, so now we are ready to reinstall the motor into the transmission. And the way we want to mount this is the connector facing out the opposite end of the wheel. Now in this case, probably hard to see, but there is a post molded into the plastic that corresponds to this hole in the motor. So really there's only one way to put it back in. If it's pointing any other way, then you know you've got your board on backwards. Or possibly you have your end bell on 180 degrees out. Alright, we'll reinstall screws for the motor. And you'll find that there's usually more grease than there needs to be, but that works out pretty well because then you can just recoat the gears to make sure they run nice and smooth and quiet. And reinstall the cover. And there you go. If you'll remember, before we started, we weren't able to get any freewheel out of this. Alright, now we're going to reinstall the transmission into the housing. Actually, I know earlier I mentioned removing the spring before taking everything apart, but I think it'll be easier if we reinstall the spring before putting everything back in. Reinstall an axle shaft. Can be tricky lining everything up. If you have a small screwdriver, sometimes that helps keep things aligned. Just carefully push the pin in. Should go fairly easily. And now we're ready to reinstall back into EUFY. Alright, so just 3 screws. Just make sure it moves freely. And we'll snap our cables. Back into place. reinstall brush motor. Next we'll reinstall our bumper switch and sensor assembly. Make sure you're not pinching any wires. Then, again, after making sure you've discharged yourself or put on an ESD strap, we'll reinstall the board. Again, making sure not to pinch any of the cables. And again, we have these two detectors that go into these slots. So you almost need to go straight down and in while avoiding pinching connectors. I'll turn it this way so you can see. And we'll start reinstalling connectors. Okay. Now at this point, we can actually connect the battery and start the machine to see if it is driving straight now. I always plug in the hopper just so that it weighs down the rear end a little bit. We'll turn the power on. Now keep in mind there's no bumper attached when it's in this state, so it's just going to go till it runs into something or you catch it. So here we go. And no more dizzy robot, looks like. So I'm going to go ahead and reassemble this the rest of the way. Again, there are no connectors of any kind on the top when you reinstall it. You just need to make sure that all the cables are clear from being pinched. And then just double check these switches here. Make sure they're not sticking. And there should be no forcing required, so if you're having to really press to join the parts, then you've probably got something pinched. I'll go ahead and turn this over. Reinstall the screws. I saw a tip on another channel, and I will link to it in the description. But if you notice your robot vacuum is bumping into a lot of stuff instead of slowing down and turning direction, there's a good chance that the window, which the IR sensors look through, is getting scuffed up. So you can actually polish this with a plastic polish like you would use for car headlights to help clear up that window, and that seems to work pretty well. So carefully reconnect your connector. Then be careful not to bend these bumper springs. This just hooks right over the top. I'll flip it over. Reinstall the lower bumper section. And reinstall screws. And while you have your EUFY apart and or upside down, it's a good time to clean the drop sensors with a can of air, or you can use a cotton swab. And also would be a good time to clean this wheel here, which just pops out pretty easy. A lot of times you'll get hair and debris built up. Let's see, there's a little bit on there. Snaps right back in. Alright, let's reinstall the brush. Snap the cover back on. Side brushes. I don't remember if I showed this at the beginning of the video, but I completely forgot to check on this. This side brush is getting ready to do the same thing that the drive wheel did, which is the motor is beginning to get a lot of carbon buildup between the commutator. I don't know if you heard that beep, but if you have the power on and you're spinning these and you're sending voltage out to the board that's causing it to beep like that, you know you did a good repair. So, clear off my work area and put a couple of obstacles up. Actually, take that back. Those beeps we heard earlier, you won't you will be able to hear even with the master power switch in the off position. So without further ado, so there we have it. Again, this one does have a brush that is going out. It doesn't seem to know it yet, but it's definitely getting there. So hopefully this helps you get your EUFY going. If you have any further questions or any faults that may not have been covered, please leave a comment, and I'll do my best to address the question either in another video or I will respond to your comments. Thank you so much for watching, and if you like this video, subscribe or like or both. Thank you, and looking forward to the next project.